Hello guys, this is CodeNCode and welcome to the third lecture of this series in which we are going to talk about the implementation of segment tree, how we can build segment tree, how we can save it, how we implement it, and how we can perform the queries. So if you are following from the previous lecture, then you know how this segment tree is built for this array. And if you haven't watched it, please go back and watch that lecture. So now if we ignore these ranges on the top of the elements, and if we replace them by index or position, then and if we give position from top to bottom and left to right, so this would get 1, this would get 2, 3, 4, 5, 6, 7, and so on. Now I'm ignoring 10 and 11 for a reason here, and then this is named for 13, and this is got the position 13. This is got 12 and this is 13. Sorry. Now for a parent with certain index, can you see a pattern of its left child? If you see, you can see that the left child is getting the index twice as that of his parent. So a parent is getting, if a parent is having an index 1, then its left child is having an index twice of it, that is 2. We can see it here as well. This is having an index 2, so its left child is getting index 4. Now this is having an index 4, for its left child is getting an index 8. Similarly for this. Now can you see what is the index of the right child of a given node? Yes, we can find a pattern 2. We can find here a pattern 2. It is 2i plus 1, that is twice of this plus 1, twice of this plus 1, twice of this plus 1, and so is true for this. Now you can see why I ignored 10 and 11 here, because 10 and 11 are actually children of this node, because this is having an index 5, so its left child is 10 and the right child is 11. That is why I have ignored 10 and 11 here, because those two elements does not exist in our segment tree, so I've ignored them, and the left and the right child of this are 12 and 13. So we can see that the root node would have a index 1, of course, because we are starting from there, and its left child would be saved at index 2 and the right child would be saved at index 3. So we can see that we don't have to make a binary tree for this. We can simply save this whole structure in a array. So at index 1 I can save -3, at index 2 I can save 1, at index 3 I can save -3, and so on. So this whole structure, which was looking quite complex, we can save it in a simple array. And again here I'm missing 10 and 11 because those are children of this, and which currently are not part of our segment tree, but those two elements exist here because this is an array. So 10th and 11th element of course exist here, but I have just not shown them here, which does not make any difference for our discussion. So we can see that the segment tree can be actually saved inside an array. So we would use it's basically use an array is used to save the segment tree. Now the only thing that we need to talk about is how we can build this tree. Now see, when we are talking about range minimum, query maximum, or anything, what happens is that a parent node takes the values of its child node and then uses those to make and save the result of its own. For example, for minimum, what it does is take result of left and right child and take minimum of that to make its own result. It does not calculate it completely, because if you have already the result of left and right range, since these two combined makes the range of its parent. That is why it does not have to recalculate all this, because the children have already calculated it. So all you have to do is merge the result of these two. Similarly for this, since the left and the right child contain the result of the segment for which we are going to save result here, so what we do is simply take these two, take minimum and save here for the range minimum. So what happens is that if we are at a node which is not parent, we would first make two recursive calls to its left and right child so that they build themselves. Until and unless they have finished their work, we cannot make result of our own. A node cannot make a result of its own until and unless its left and right child have built their own results, because a node depends on his left and right child to build his result, so they must be built before him. So what happens when you are not the leaf node, since leaf nodes are the only nodes, we do not rely on any other node for their result. They can simply take the result from the original input array. So if you are at a node which is not a leaf node, you make a left and right recursive call and then build the left and the right child and then take their result and build your own. So keeping this thing in mind, this is the code for a segment tree. For example, we are building a segment tree for 3 elements, 1, 2 and -3. So the segment tree would look something like this. The root node would keep the result from 1 to 3, and the minimum of range 1 to 3 is -3. Now the mid of 1 to 3, 1 plus 3 divided by 2 is 2. So the left child would keep the result from 1 to 2 and the right child would keep the result from 3 to 3. Now since this, when you were here, since left and right child have not built their solution yet, so what you would do, you would make a recursive call to left and right child. Now let me show you what these things are. Sorry, I made it to return integer, but it would return void because it returns no value at all. So now SI, SS and SE. Now SI is the segment index. Segment index is the index at which the at which the result of this node would be stored. And we know in the segment tree, this is the segment tree array. In the segment tree, the root saves its result at index 1 and its left child saves its result at 2, and this would return save its result at index 3, because the left child is twice of it. Since it would store its result at 1, then this would store result at 2, that is twice of it, and this would store the result at 3, that is 2i plus 1, twice of index of its parent plus 1. So SI is actually the index at which in the segment tree array we are going to save this result. So SI is the segment index in the segment tree, and SS is the segment start, and SE is the segment end, that is these two values, segment start and segment end. So now if the segment start is equal to segment end, that is this, the base case, like this, this and this. If you are at the leaf node, so you do not need anyone else to build your result. What you can do is you can take the result from the input array. So what happens here is that we are at root node and it have to keep the result from 1 to 3. Now since this is not the leaf node, so what it would do, it would make two recursive calls to left and right child. Now whenever it would make a left call, it would pass the index to be 2i, that is, since the segment index is SI, the segment index of left child would be twice of it, so we are passing twice of SI, and then segment start would be start of the previous segment, that is 1, and the segment end would be mid. We have already calculated the mid, so segment start would be the segment start of the current node and the segment end would be mid. So first recursive call would be to 1 to 2 with segment index segment index 2. Now the next recursive call would be from mid plus 1 to segment end. So mid plus 1 to segment end. Segment start would become for the right child, segment start would be mid plus 1, and segment end would be segment end, of course. And the segment index for the right child would be twice of the current index plus 1. So twice of it plus 1. This is the index at which the result of this node would be saved in the segment tree array. This is the segment tree array. So once we have built the left and the right child of it, we can take their result in the segment tree. At this index is the left child, at this index is the right child. We can take minimum of these two and then save it at fi, which is the result for this node. So what happens here is for 1 to 3, we see this is not the base case because segment start is not equal to segment end. So we calculate the mid, which is 2. We make 2 recursive calls, 1 to 2 and 3 to 3. Now for as soon as we reach 1 to 2, since this is again not the base case, what happens here is we again calculate the mid, which is 1 in this case. So we make 2 recursive calls from 1 to 1 and then 2 to 2. Now the result of 1 to 1 would be saved at index 1, 2 and 4. The result of 1 to 1 would be saved at index 4. So at index, sorry, this is result of the left query. So from 1 to 3 we made 2 recursive calls from left to right. Since the left call goes to what we say is a leaf node, since segment start is equals to segment end. So what we do, we take the result at segment tree at index in the segment tree at index 3, because the parent was having an index 1, so it would have an index 3, twice of the parent plus 1, that is 3. At index 3 in the segment tree, at index 3 in the segment tree, we would save the result of range 3 to 3. Now we can see the result at 3 to 3 is minus 3. So at index 3 we would save minus 3. We can see here that at index in the segment tree at index si, we are saving the array element ss. You can take segment start or segment end, doesn't matter, because segment start and end both are equal. So at index 3 we would save minus 3. Now since the right call is completed, so we have this result to build this node, but we don't have result of this node. So we reach here at 1, 2, but since this is not again the base case, so we would make 2 recursive calls to left and right child. Now to the left of it we have index 4. At index 4 we would save 1. So at index 4 we would save 1. At index 4, basically as soon as we reach index 4, here segment start is equals to segment end. So at segment index in the segment tree we would save the result from the original array, and we can take it from here, that we can take the result from segment in from array at index ss or se. So at index 4 we have saved the result of this part. Now 2 2, since the segment start is equals to segment end, and hence this is the base case. So at index 5, since this is having an index 2, so it would have twice of 2 plus 1, that is 5. At index 5 in the segment tree we would save the result 2. So whenever segment start is equal to segment end, this is the base case, that is you are on a leaf node, that is in your segment there is only a single element. If in your range there is only a single element, then that element itself is the minimum, or for maximum query that element itself is the maximum. That is why at the index in the segment tree we are saving that element itself. Now since at index 4 we have saved 1, at index 5 we have saved 2, at index 3 we have saved minus 3. Now since the left and right child have completed their results, now this node can compute its result from left and right child. Now what happened here is that we made a recursive call to left node, we made a recursive call to right node, Now since left and right are now completed, we can take minimum of left and right and save into this. So the minimum of 1 and 2 is 1, so at this index we save 1, at index 2 we save 1. Now we can take minimum. Now the left and the right call for this node has completed. Now it would take minimum of these two and save the result at index 1. So finally it saves -3 at index 1. So we can see that if the segment start is equals to segment end, what we are going to do is at si in the segment tree we are going to save the element itself of taken from that input array. Otherwise we calculate the minimum, the mid element, and then we make two recursive calls to its left child, that is 2 into si. The segment index of the left child would be 2 into si, the segment start would be ss, and the segment end would be mid, from start to mid. And then the next recursive call would be at index 2 into si plus 1, and then the segment start would be mid plus 1. Since we have already calculated the result from segment start to mid, now we have to start a result from mid plus 1 to segment end. Now since the left and the right child have been built, we can take out their result to build our own. So this way you can build the segment tree. And finally the query. Since we have from the previous video we know how the query works, and we know if we go completely outside what happens, and if we are completely inside what happens, and if there is if the segment is not completely outside or completely inside, we make two recursive call and return the result from there. So what is happening here is that, first of all, in the query function we have si, ss, and se. We already know what these things are. Si is the segment index of the segment tree because we can take out the result from there, and then ss is the segment start and se is the segment end. Of course, the segment start and the segment end of the current node in the segment tree. Now the query start and the query end is the left and the right points of the segment of the query. For example, if I want query from 5 to 12, then the segment start would be 5 and segment end would be 12. So now in the query function we have si, ss, se, qs, and qe. Now if we are completely outside, for a range minimum query we would return infinity. That's this infinity can be int max for C++ user, which is the maximum value which you can store in 4-byte integer int max. So we can return the maximum value, that is infinity. So if query starts when the segment has already been ended, so we are outside the range, or if the query ends before the segment has started, so in both the cases we are outside the range, outside the query range. So if we are outside the query range, we have seen in the previous video, we return infinity. If the current range, that is segment start and segment end, is completely inside our query range, if this is a completely inside case, then we return the value of that node in the segment tree. So what happens there, if segment start is greater than or equal to query start and segment end is less than or equals to query end, then in that case we return the result saved at this index. Otherwise we calculate mid, we make a recursive call to left, we make a recursive call to left child, and we take out the result from there. We make a query on the left child, we make a query on the right child, and whatever is the minimum of that we return. So for the left child the segment index would be 2 into si, and for the right child would be 2 into si plus 1. Now the segment start would be segment start and segment end would be mid. Now the query start and query end don't change at all because the query segment don't change. And for the right child, segment start would be mid plus 1 and segment end would be se. So this is how you can return the query. And I'm not going into deep detail of this because we have already seen how the query is performed on a segment tree in the previous video. This is just a reflection of that. So you can solve the first question. I am putting the link in the description. You can solve that question using only the knowledge of the thing that we have learned till now. And since that question is very easy, because that question totally asks you to print the range minimum, so you can solve that problem by yourself. So try to solve that, and I'm also going to uh, put a link of the solution of my solution of range minimum query of the same problem. So I'm putting the link of problem and solution. So try to solve the problem by yourself. And yeah, one more thing, the segment tree takes if the array size is n of the input array, then the size of the segment tree is 4 times n, that is 4n. You can check out the proof of this, why we required at max 4 in space. So thank you guys for watching, and keep coding. Thank you.